Okay, sir.
கணிப்பீங்க.
Sure.
ஓகே தேங்க்யூ சார். இப்போ எவ்வளோ சார் சாங்ஷன் பண்ணியிருக்காங்க டிஎஸ்டி ஃபெஸ்ட்?
Fist எங்களுக்கு 27 lakhs சார்.
ஓகே சார். லேபரேட்டரி செட் பண்றதுக்கா சார் அது?
லேபரேட்டரி செட் பண்றது சார்.
ஓ சூப்பர் சார், சூப்பர்.
ஸ்டார்ட் பண்ணிக்கலாமா சார்?
ஓகே சார், ஸ்டார்ட்.
ஓகே சார். சார் நீங்க இன்ட்ரோடக்ஷன் கொடுத்துருங்க சார்.
ஓகே சார். Very good afternoon to one and all present here, and first I will give the brief introduction about the resource person and thank you for one and all for joining us. M.KARUPPASAMYPANDIYAN is working as an assistant professor in the Department of Electrical Engineering in Kalasilingam University, Tamil Nadu, India. He completed his BE degree in Electrical and Electronics from KLN College of Engineering in 2011 and obtained his M.Tech in Power System Engineering from Kalasilingam University in 2014. He has 12 SCA publications and more than 20 Scopus indexed publications. He completed 3 funded projects and he has one ongoing project also from government funding agencies. He has received a Professional Achievement Award from IEEE Madras section in the year 2017. He acted as an executive committee member of IEEE MAS Young Professional Society in the year 2017 and also in 2018. He received a Dr. Sarvapalli Radhakrishnan Best Faculty Award in the year 2021 for his commitment and dedication in teaching and research in electrical engineering from CPAS India. He also worked Young Scientist Award from SCA Father for the year 2021. He is MathWorks Certified Matlab Associate Developer. His area of research is applications of AI techniques in power system. And I have searched his LinkedIn profile and also other profiles. He has more than 50 publications. So I urged Dr. M. Armu Babu sir for a long time to conduct this webinar. And thank you, Armu Babu sir, and thank you, Karuppasamy sir, for joining us. It's our pleasure to take this webinar, and I think we will get more input from you, and we will continue this type of webinar in future also. Thank you for joining us, sir. Over to you, sir.
Thank you, sir. Thank you so much for the invite, sir. I thank management of CKEC Engineering College and also the HOD sir, Dr. Armu Mobu sir, for the opportunity to share my knowledge with you all on the topic of optimization techniques and its implementation on Matlab. I will share my screen. So is my screen visible, sir?
Yes, sir.
Yes,
Your screen is visible.
Yes. Thank you, sir. Thank you. The session is about optimization algorithm and its implementation using Matlab. Maybe I'll take most of the time for hands-on training, but maybe for first half an hour I'll just recall some of the basics about optimization technique, so that it'd be very easy for us to understand how we can implement the same thing using the Matlab platform. So I just want to list out the contents to be discussed here. So we'll start with first computing, because the optimization one helps to solve the problems. Then we'll take up some of the introduction about optimization algorithm. More specifically, the algorithm called the genetic algorithm. So I think the genetic algorithm is the mother for all other algorithms. Day-to-day life, we are getting a lot of new algorithm, but for all those things, the genetic algorithm is actually a mother, like a mother. So once we understand the genetic algorithm well, so we can easily understand all other algorithms also. So let us take genetic algorithm, some of the basics. Then also we try to implement the genetic algorithm by using Matlab, by taking some of the power system applications, and finally we have the question and answer section. So generally, the optimization techniques used to solve the problems. So problem instance we used to call computing. see, computing in sense, it's actually a mapping function which maps the some of the input data with the output data. So the input data we used to call antecedent and output data we used to call consequence. It is generally computing is basically a mapping function which maps input with the output. So generally there are two types of computing. One is hard computing, other one is soft computing. Both are actually proposed by the scientist, mathematician scientist called Jet. It's a hard computing which we use day to life to solve a lot of numerical problem where we have to follow certain rules, certain algorithms, and the result generally will be very accurate one. And like this solving normal numerical problem, getting the roots for a polynomial equation, or finding integration or differentiation, all comes under the hard computing, which for that we need to follow certain rules and certain formulas. And whereas on the other hand, the soft computing again that also be proposed by the same mathematician, where we no need to follow any certain rules or any certain algorithms, and we can't expect the result also to be accurate one. The result sometimes may be inaccurate, and it may be closest to the actual the result. And wherever the problem which can't be converted into a mathematical problem, we can actually solve those problems with help of the technique called soft computing techniques. And as I told before, the soft computing technique does not need any definite algorithm, so it may change with respect to the particular problem. And also it is only provide the nearby accurate solutions. So in this entire session is about the soft computing, how we can solve the soft computing, how we can apply the soft computing to solve the some of the optimization problems. So I just list out the difference between the hard computing and soft computing. Hard computing always deterministic, that is, it generally follow the certain rules or certain algorithm. The best example, doing integration and differentiation, even doing addition or subtraction, we have to follow certain rules. For soft computing, it is not like that. It is generally probabilistic, and it depends on the particular problem. And hard computing generally requires the exact input what we need to do, whereas soft computing it is not like that. So we sometimes the input may be some uncertain input. And as I told, hard computing has to follow some sequential process, whereas it's not like with the soft computing. It may also follow the parallel computation. And hard computing generally give the exact precise answer, whereas soft computing will get the approximate answer nearer to the actual one. So I just list out some of the soft computing techniques here. The first one is ANN, artificial neural networks, and the second one fuzzy logic, and the last one the genetic algorithm. So actually, artificial neural network, it is like how we actually learning in our childhood. The same actually mimicked as the computational technique, which we used to call artificial neural network. So let us try to understand the artificial neural network by taking one simple example. So in class, actually, the students learning from the teacher. So generally, student first the teacher explains something, and the teacher asks some questions to the student. The students will take a hint, and maybe the student will learn from the teacher, and the student may study from the book and etc etc. And based on the remembrance he having and his brain, he will answer for the question which is asked by the teacher. The same way, actually, the ANN workings. ANN has to learn first, as like the human brain learning based on the some of the experience. The same way ANN also learn, and based on that, it will solve the particular problem. So I give one such example for the ANN. So it's application for recognizing the handwritten character. So as I told, the ANN will learn based on the information which we are giving. So for making the ANN to learn, we have to give both input data as well as output data. So we know actual A, how the A looks like, and we have to give the different handwritten A to the ANN network. So ANN will learn and all those patterns, the A patterns, and after sometimes once we made the ANN to learn and we give the character A, it will just recall actual character which we already given, and based on that, it will answer like the given character is A. It's just one example. Likewise, we can make use of ANN for any such application. Then the other technique called fuzzy logic. So wherever you have a randomness, we can actually go with the fuzzy logic. And for that, we can understand fuzzy logic with an example. It is like if we want to uh, know our medical health, and we will generally go and meet a doctor, and the doctor will try to diagnose based on the problem you are having. Doctor asks some question, and from that he try to understand what is the problem you are having, and he may sometimes prescribe some test and medicine. And see that generally will not be always same. And we can't expect that will give the solution for us. So it depends on the particular situation, or it depends on the particular condition. So likewise, the fuzzy logic also give a solution, but it will be like a normal accurate solution, but it will give solution closest to the actual answer. So we use generally fuzzy logic wherever we have a randomness, both on input side as well as output side. And again, I give one real-time example. This is actually for robot movement, and for robot to follow the certain path, we actually go with the fuzzy logic application. So, see, the robot has to follow some rule, and it has to avoid the obstacles. You can see there are some of red box I put here that are obstacles. So, robot has to move from one place to other place. Whenever any obstacle comes, it has to move from that obstacles to, it has to find other path. So for that, we have to actually, we can apply the fuzzy logic, and we can solve this problem with the help of the fuzzy logic. And last one is the today session is about the optimization techniques, which is generally used to solve the some of the mathematical problem which has some constraints, and or which has some equality constraint and inequality constraints. So we generally optimization algorithm used to solve the problem where we need to get the minimum value, or we need to get the maximum value. One such example, real-time example. Let us say I want to invest my money in different banks. For different banks having different policy and etc. etc. And by applying the optimization algorithm, I can know in which bank if I deposit money, I'll get a maximum return, maybe in terms of interest or maybe any other benefits. For solving those things, we can actually apply any of the optimization techniques. So let us start with the today the optimization, one such optimization techniques. We'll quickly understand the process of a genetic algorithm. Then I will take over to the hands-on training on this particular algorithm on the Matlab toolbox as well as Matlab coding. So GA is actually one such optimization algorithm, which is generally based on the natural genetics, or natural evolution. So that's why it is termed as a genetic algorithm. It is generally used to find out the best solutions. In sense, it may be a best minimal solution or best maximum solution, which depends on the particular problem. It generally follows certain process, and the name of those process similar to that of our human natural genetics process. We'll try to understand all those process one by one. So before that, I just shown the evolution of genetic algorithm. It was originally proposed in 1865 by the scientist Johann Mendel, which is called as genetics. Then it was again somewhat modified by Charles Darwin in 1875, and he proposed the evolution concept to solve the simple optimization problem. And after that, Professor John Howland, he invented the genetic algorithm concept in 1965, and from 1975 onwards, it is accepted throughout all the research community, and we are using GA for solving plenty of problems. So actually, the genetic algorithm, I'll just show you the flow chart. So this is the overall the steps involved in the genetic algorithm process. So whenever we take a problem, the problem generally having some solutions. Let us say I want to solve the problem called x squared plus x. So that x may be any number. It may be from minus infinity to plus infinite. So that we used to call such space. So the solution, the number actually between any of this, that we used to call actually solution space. And then from that solution phase, you have to pick up the actual population, and again the population is not should be between minus infinity to plus infinite. it may be between any of the two limits, and again it is depends on whatever the problem we are going to solve. Maybe some problem needs the actual variable between the some variable, let us say example 5 to minus 5 to plus 5. Then we have to take all the possible variable, all possible solution from minus 5 to 5, which we use generally called the such space. Then from that such space we have to get, for all the such space we have to get the actual objective function or fitness function, and again that fitness function is depends on the particular problem. Let's say you can say mathematical example of x squared plus x. Now that is actually a fitness function. Sometimes I may need to minimize that function, or I may need to maximize the function. So based on that, I have to get the solution for all my such space, which may be between minus 5 to plus 5 or between any of the two number. Now after that, we need to apply the genetic process. So I'll explain those process with help of the flow chart. So these are the steps involved, and let us take this flow chart. So we initially needs to create a population. So the population is like the solution space that we used to call actually populations. Uh, um, and then once we have created the populations, then the number of population, and we can decide as a user, we can decide how many number of population I want to create, and between which such space I want to create the population. That we can do. I'll show you how we need to do while we solve the problem in the Matlab. So once you have created the number of population, for all the population we have to evaluate the fitness value. The fitness in sense we have to get actual objective of that particular population. Then we have to see it is actually all the optimization algorithm will run for multiple times, that we used to call the iterations, and we have to check for convergence whether the optimization algorithm is over or not. There are different way to check the convergence. One such way is to check whether the problem reaches maximum number of iteration, or else we will check for whether it exceeds the tolerance value. Like that, there are a lot of different ways to check whether the algorithm is converged or not. Once the algorithm is converged, we can stop the process. If not, we need to go for a genetic process. The first genetic process in the genetic algorithm, we have to select the individuals. We have a lot of solutions now. From those solutions, you have to select the best solutions. And for selecting the best solution, we have a different methods. Maybe in the upcoming slide I will show you what are the different method we can apply to select the best solution. So once you have selected the best individuals or best solution, then we generally go for the creating the new variable or new individual that we used to call reproduction. So there are different steps involved in reproduction. Now the first step is to create the matching pole, then crossover and mutation and inversion. So these are general steps. So this is actually all those processes and all the algorithms almost the same. When algorithm changes, they only change the terminology. Instead of crossover in other algorithm, they may use other word. Instead of mutation, they may use other word. But if you look deep into it, it is like the same thing what we're actually doing on the genetic algorithm. So once the reproduction sense, it's creating a children from the parent, that we used to call actually reproduction. The once we have created the new solution, then again we do the same process. Then for those new solution, we used to call new individuals. For that new individuals, we again go for a fitness evaluation, and then we do the same process until the entire algorithm is converged. So this is what the normal algorithm for a genetic normal procedure to implement the genetic algorithm. So let us take the process one by one quickly. The first one is actually a population creation. So while we create a population, there are two ways to create a population. One, we can make a binary encoding population, others real encoding population. So binary encoding population instance, for example, my such space is from minus 5 to plus 5. So what I do is I'll convert that real number into a binary number, and then I use that binary number as an actual population. I'll do all those operations for that binary number. Once I solve the problem, again I'll convert my solution into binary variable to actual number. That is what actually binary genetic algorithm. And nowadays we won't use that binary genetic algorithm, because it is obvious that we need to convert right one number to other number. It obviously takes some time. So that is actually old way. And but after that, we have other genetic algorithm called real encoding genetic algorithm, where we directly get the actual number, actual solution between the boundaries, maybe minus 5 to plus 5. With that, we go for the other steps. That is we used to call a real coding genetic algorithm, a real encoding genetic algorithm. So I am going to demonstrate using Matlab in real encoding genetic algorithm. So once we have created the populations, then we have to go for fitness. And again, the fitness is depends on the particular problem. If it is a mathematical problem, we have a mathematical equations. If I take in the power system problem, we well known the problem is economic dispatch problem, where we have a where we need to minimize the actual fuel cost of a generator. For that we have some equations, right? That we actually called as fitness functions. And for that fitness function, we have to get the fitness score by applying the population we have created. So once we completed the calculation of fitness, as I told, next we need to go for a selection process. So we have now n number of solution for n number of variables. So now in that I have to choose which is best, that I used to call selection techniques. Generally, there are 5 types of selection technique used in the genetic algorithm. The first one is canonical selection, and second one roulette wheel selection, third one rank based selection, and fourth one tournament selection, last one steady state selection. Let us try to understand one by one very quickly. First, in canonical selection, it depends on the average of an best individual. So we will get fitness value of for all the solution, all the population which were created. Then we try to get the average of all those things, and whichever the variable which is closest to that average value, we choose that as a best individuals. For example, let us imagine I have chosen 5 population. Let us say 5, 10, 15, 20, 25. These are all the population I have created. I'll try to get the fitness function for all these 5, for 5, 10, 15, 20, and 25. I'll get the optimization, that is I'll get the fitness value as the average of fitness value as, let us say example, 28. Now the 28 is actually closest to the fitness function as actually the last one, nearer to 30, right? So I'll choose the 30 as a best individual now. So this is actually canonical selection, right? It is purely based on the average, overall average of a fitness function. That is what the first method. But nowadays, for we won't use actually the canonical selection because it won't select actually best individual, because it is not involves actually the fitness function. So the fitness function, it may be minimized function or maximized function. If it is a minimized function or what are maybe minimize or maximize, it is not looking it minimize or maximize. It is generally looking for the average. So this is actually oldest one. So we won't use actually this canonical selection as a selection process in the GA application. Then the second one is actually roulette wheel selection, where we actually divide. It is like a wheel. What we do, we'll get the fitness of all the variables. Let us take. I listed here there are 8 individuals, and for those 8 individuals, I also listed the random fitness value. So we will probabilistically, that is, we will probabilistically separate all those individuals based on its fitness value. The individual which has the large individual in sense population. The population which has the largest fitness value will be given to the largest percentage in the wheel. Likewise, we'll allot for all the individuals some of the percentage that is proportional to the actual fitness value. Then we just randomly rotate this roulette wheel for NP, that is for the number of population. If number of population is 8, I'll rotate for 8 times. After I rotating 8 times, wherever I have a largest percentage, in which individual I have a largest percentage, that individual will be selected as a best individuals. And again, there is a problem with the roulette wheel selection. There we actually choosing the best individual randomly, so it also leads to some inaccurate the answer. The next one actually rank based selection. So because in roulette wheel selection, it will not look for actual fitness. Instead of that, it is randomly making the selection of a best individual. Whereas in rank based selection, we just rank all the fitness, all the individual based on the fitness early in ascending order. So one which has the lowest will have a rank 1, lowest fitness will have a rank 1, and then rank 2, rank 3, and so on. And based on that, we'll select the best individual. It's normal rank based selection. So this is the overall the comparison of rank based selection and roulette wheel selection. So I have taken for 4 individual here, and I randomly put the fitness function. So based on the fitness function, I actually allot the roulette wheel proportion. The first one having actually largest fitness function, it is nearly zero point 0.4, which is allotted with the 80 percentage of the roulette wheel, and 0.05 10 percentage, 0.03 6 percentage, 0.02 4 percentage. So this is how actually the roulette, see, it has actually largest thing. So it generally it choose the first individual, whereas in the rank selection we actually ranking all those percentage we are ranking. So the first which has the lowest thing, lowest fitness function, so I just rank it as a 1, then second one 2 and 3 and so on 4 and so on. So obviously this will be selected as a best individual for the next generation. But here we can't expect this will be selected, right? Because we have to rotate this roulette wheel for 4 times, because we have 4 individuals, so we have to rotate this roulette wheel for 4 times. After we rotate 4 times, so when you look where we have the largest proportion, that we have to choose as a the best individual. The next one, the tournament selection, it is like knockout selection, where we select the number of individuals at random. Maybe if I have a 10 individual 10 population, I'll select randomly 5 population. From that I'll choose the winner which has the best fitness. The best fitness in sense, sometimes the problem may be minimize function, or sometimes the problem may be maximize function. So based on that I have to choose. If my objective is to minimize, so I look for the fitness which has the very lowest value. If my fitness is maximized, then I have to look for the fitness which has the maximum value, and based on that I'll choose that as a winner, and I'll repeat the same procedure up to I got the number of population. So it is just normal tournament. We'll just pick up randomly some of the fitness, and from that we'll choose the winner which has the best fitness, and we'll repeat the same step until we got the next individual, that is next population is equal to the old population. So this is one such example I listed here. So it will go for a different trials. We have taken here 2 individual randomly for a n, that is 8 number of individual. We have taken 2 at a time. For the 2 we have selected best one. So we'll keep on doing it until we got the selected. Totally we have selected 8. But if you see here, after we selected the best individual, if you take the first trial, I randomly chosen 2 4, the second individual and fourth individual. In that second individual having the fitness of 2.1, fourth individual having fitness of 4. So obviously 4 is the largest. So let us imagine this is to get the maximum value. So I have to go with the 4 as a selected variable. Similarly, the second time we are choosing 3 8 and so on. We are doing it for 8 different times. So after that we can see that there are 8 selected 2 times. Okay, so there is a tie between these two. So for that again you have to go for a trial, and you have to select the best one. Okay, so we have to repeat this process until we get the number of the selected population equal to the actual individual. Then the last one, steady state selection, and again it is like selecting the n number of individuals at random. Then we just remove the worst fitness. The worst fitness is, again, if it is a minimum function, whichever have the maximum fitness, we'll remove that. In other hand, if the objective is to get maximum, then we'll just remove the function which has as the lowest value. Then after that we'll go for the next process, that is matching process. So this is what the selection procedure. So once we calculated the fitness, we need to go for a selection based on any of the method which we've already seen. Mostly we'll use tournament selection, or else we use roulette wheel selection in the genetic algorithm process. The next one is reproduction. So once we selected the best individual, now we have a two separate thing. It is like a parent. Now from that parent we need to get the child for the next generation. So the reproduction involves three operators, like a crossover. We'll do first a crossover between the two selected individuals. Then we do mutation. Then finally we do the inversion process. So again, the crossover, mutation, inversion having a lot of other types also. Let us see quickly first. See, crossover, as I told, it is like matching two parent and getting the children. And the children we used to call offspring. And there will be different types of a crossover. the one single point crossover, 2 point crossover, multi-point crossover, uniform, half uniform, shuffle, matrix. See, the crossover is nothing but, so let us imagine this is actually one individual and this is another individual. So we just mingle these two, parent one and parent two, and we'll try to get the new solution. We'll try to get the new variable that we used to call children, or we used to call here in GA process we used to call that as a offspring. So that can be done in a different way, like using a single point or 2 point, multi-point, and so on. So once you have completed the crossover, next we have to do the mutation process. A mutation is like just a muting, that is just a flipping the variables. If it is a binary, we'll try to convert 1 to 0 or 0 to 1. Just flip. And again, the mutation can be done for entire variable. In sense, if I have a number called 8, I'll put mutation. Now the 8 may be changed to 5 or 2 and so on, depends on what types of mutation we are applying. Instead of that, we may also apply mutation for a specific bit. Maybe if I convert 5 into binary number, I'll have a 4 or 3 or 4 bits. So in that specifically, I can convert any one of the bit either 1 to 0 or 0 to 1. So once the mutation over, next we need to say this is the actually mutation process. It is a binary mutation process. It is just a flipping the bit or interchanging the bit or reversing the bit. That means 1 to 0 or 0 to 1. Same only shown here. Same, all are interchanging reversing process. So once the reproduction over, then we have to repeat the same steps. So now after the reproduction step, we have a new set of variables, or we used to call new set of populations. It is similar to that of new children's now. Now again the genetic process start. We have a new set of population. For that, I have to again get the fitness function. Then for that fitness function, I have to apply the selection process. And again, for that selected variable, I have to apply the reproduction. Then again, new children will come. Again, the same process repeat until I got the expected result, or else until I set the number of generations. Maybe I want to repeat the process up to maybe 50 or 100 iterations. It will check once it over and it stop the process and it will display the actual result. So this is how actually all the optimization algorithm works. First, always you have to create the populations. Once you created the population, you have to go for a fitness function evaluation. Then depends on the algorithm, the terms may change. In GA, we used to call the selection and reproduction and convergence checking. It's a similar way in other algorithm. This terminology may change, but if you deep look into it, all are having the same process. So now let us we'll say okay. Let us see now how we can implement all those things using Matlab. So Matlab generally offers two ways to solve the optimization problem. One is by writing normal Matlab code, that is used to call M5. The other one by using a toolbox. So Matlab offer optimization toolbox. With that, we can solve the optimization problem using a GA, and even we can solve multi-objective problem also with help of toolbox. First, I'll show you how we can apply toolbox. For a toolbox application, only thing we need to know how to create the objective function. So once you have created objective function, and we can easily able to solve by means of the toolbox. And also I'll show you next how we can make a programming. I already having some certain programming. I'll explain how we can make use of that programming. So we can use that particular program for any of the application. Only thing, once we know how to make a optimization function or a fitness function, it is very easy to incorporate those function any of the optimization algorithm, not only in GA, any of the optimization algorithm. So you know that all the optimization algorithm already available. It was generally developed by the mathematicians. So we can use that optimization algorithm to solve our domain problem. Only thing we need to know how we need to replace the optimization algorithm, our optimization algorithm, with the actual the proposed optimization. Now I'll just open. I'll start with first one simple mathematical function, and then we'll look into some of the optimization algorithm. So this is one of the mathematical function. It was named as Mortis function, whose objective or fitness function is f of xy, it is a two variable function, equal to 0.26 x square plus y square minus 0.48 xy with a constraint of minus 10 to plus 10. That means the xy should be between minus 10 to plus 10. Actually, this optimal solution for this particular fitness function is 0. 0 is the actual optimal solution. Let us try to solve this particular problem using Matlab toolbox first. Then also I'll show you how we can write a programming for this. I'll open Matlab. So it's my Matlab screen is visible, sir.
Yes, sir. Visible, sir.
Yeah,
Fund,
thank you.
it is visible.
Yes, sir. Thank you. So yes, I told Matlab offer two way to solve optimization problem. One thing we can straight away write the program to solve, or else we can use the inbuilt toolbox to solve the problem using optimization. First, I'll show you how we can use optimization toolbox. For that, we need to go to the ops. There you can see in ops optimization. You, you just click this, or else in the command window we have to type optim tool to open this particular toolbox. So this is actually the optimization toolbox front panel, where you can see the first one is actually solver. So it actually give the different solver to solve the optimization problem. Some of the mathematical method also listed here, like the constraint nonlinear optimization minimization, nonlinear constraint non-constraint linear nonlinear minimization, and minimax optimization. Likewise, there were different way to solve the problem. We actually going to use today as a genetic algorithm. So even we have a multi-object genetic algorithm also available in the recent MATLAB toolbox. So I'll choose GA because we are going to solve with help of genetic algorithm. So once you choose on GA, you can see on that the right side, it will give the options like how many population I want to create, and what is the fitness, what selection method we need to apply, and what is the reproduction technique you want to apply, what is the mutation techniques we need to apply, and crossover. So there are a lot of options are there already. The defaultly it is set, and if you want to change, you can also change it. Generally take population size as 50, and if you want to specify, you just click and you just set the actual number. I want to set the population size as 100. Likewise, you can set for all the other things also. I'll go with the default value. Then we have to make the fitness function. So we have to first create the fitness function, and the name of the fitness function should be put here. Let us see how we can make a fitness function. I'll go to again MATLAB front panel. There you click new and function. I want to create a function, so I'll create a function now. You go to new and create a function. So once you click created a function, it will show the actual standard format. Generally function means we have to give function name. This is actually function name, and then arguments, the input arguments we have to give, then also output you have to specify. This is actually header. Then we need to write up the actual mathematical calculus we have to do here. So I'll take the mathematical functions we showed before. The function is actually 0.26 x squared plus y squared minus 0.48 xy. So we need to give a two input, right? X and y is the input. And I'll take x as a x1 and y as a x2 now, and I'll try to type this equation straight away. So I'll take the output as let us take output as z. Z equal to, the equation is 0.26 into x squared. So x I'll take it as a x1, x1 squared plus x2 squared and minus 0.48 into xy. So x I'll take it as x1 into x2. So I'll change the name of this function as let us say I'll save first. Let us say let us take objective one, opz1. So automatically this also I can replace with the actual function name, and the input variable I take as x as the input variable. We need to specify the number of input variables 2, so it will take x1 x2, and I have saved the answer in EZ. So let us replace this with EZ. Only one output, so I'll replace that with EZ. That's it. This is what the function. So we have just specified the function name as objective one, and I pass the input parameter as x. Then I type that mathematical equation: 0.2x 26 x squared plus y squared minus 0.48 x into y. And constraint you have to specify on the toolbox. I'll show you how to specify the constraint. The constraint means xy should be between -10 to +10. This is how we have to create the first objective functions. Function name, then the actual input variable, then actual equation, the problem you want to solve. So once you have created this, and I'll open again toolbox. So in the toolbox, in the fitness function row, we have to specify the name of the fitness function, and that should be specified with the at symbol. You have to put first at symbol, then you have to type the name of the objective function which we already created. So we have created the name it obj1, so I'll put the same name here at the obj1. Then you have to specify the number of variables. So you see this equation having two variables, x and y variable. The number of variables is 2, so I'll put the number of variables 2. Then we need to specify the constraints. See, this particular problem does not have any inequality constraint and equality constraints. There is no linear inequality and there is no linear equality constraint, so both we can left. But we have a bounds. So bound in sense it has some certain lower value and certain higher value, right? That is, in this problem it is -10 to +10. So x, y both are having minimum of -10, maximum of +10. So we have to specify that first. Lower value, if it is only one variable, we can simply type. If it is a two variable, you have to put a square bracket. You write for first variable lower bound. So first variable lower bound -10. Then you give some space. Then you type second variable lower bound. Then you close. If you're having maybe 5 or 6 variable, you have to type the same way: first variable, second variable, third variable inside the square box. Then upper bound, again I said upper bound, again we have a two variable, right? So two upper bound you have to specify. So upper bound for this particular problem is 10. First variable 10, and also second variable 10. So both I'll close now. So this is how you have to specify the lower bound and upper bound for the particular problem. So the first thing, you have to create the objective function, and then you give that name started by at symbol. So you have to start with at symbol only. You put at symbol, then you type the name of the objective function you already created. Then you give the number of variables. Then you have to give the constraint. If any of the constraint not there, you just left. If it is there, you have to fill up that. For this particular problem, we have a lower bound of -10. Both variable -10 -10. Upper bound is +10 +10. Once you are given all those things, you can make You can click just to start to make the optimization algorithm to start. I'll specify some of the graphs also here. You can see there are different plot options are available. So I'll try to draw best fitness and also the stopping criteria. Maybe likewise you can select whatever you want. So once you set, and also you can change all those things here, number of generation, number of population, and mutation, crossover, all those things you can change here. So once you've chosen everything, you just click start button. See, now the optimization started. See, now after nearly 40 5 iteration, the optimization get terminated because the tolerance is less than the actual value. So the objective function is 7.96 into 10 power minus 7. That means 0.00. It is closest to 0. And the optimal variable, you can see, if you want to know, there are two variables, right? The optimum variable, you can see, you can found down. The first x is 0.005 and the optimal y is 0.004. X is 0.005 and y is 0.004. And it is actually converged at 91st iteration. The same we can also see in the graph also. Okay. Not no, it is not actually nearly 40 44th iteration. It is get solved. It ran actually for a 40 nearly 45 generation. And the upper one is actually a fitness curve. You can see initially the value is nearly 20 initial value. So once the optimization started, it is getting decreased. So the thing is that this toolbox always take problem as a minimization problem. It always try to minimize the function which you are given in the objective. So now the thing, if you sometimes we also may to get the maximum variable for that particular function. If it is so, you just make the function as a one by variable. Let's take the same problem. The same problem now I want to make maximization, right? So I initially I take this the minimization problem. Now I want to maximize the eject. I want to get as much as maximum eject for a variable of xy within the limit of minus 10 to plus 10. For that case, you have to put 1 by that particular equation. That's it. So that now the toolbox will solve the problem as a maximization problem. Okay. If you're not specifying anything, it always solve the problem as a minimization problem. Now I'll go for a optimization. See, now we are getting solution as 0.01 and 0.00569, and this is actually 1 by answer. If you want to get actual solution, you have to inverse it. That will be the actual answer. 1 by this will be the answer, and you see the x1 is actually x's we are getting minus 10, y we are getting as a plus 10. If you take both are the largest value, we'll get a maximum value. So this is how we can convert the problem into maximization also. So please remember, in GA toolbox, always solve the problem as a minimization problem. Whatever function are specifying that looks for, always try to minimize. But if you want to solve maximization, you just make that fitness as a 1 by actual optimization function. So this is how we can use optimization toolbox to solve. And I'll take one more example, which we use generally in power system application, which is the economic dispatch problem. I'll take economic dispatch problem now. So we know that in economic dispatch problem, the optimization function is a minimization of fuel cost. And we know that the minimization of fuel cost formula, A PJ square plus PA PGA plus CA, that is the general equation, subject to the uh, bounds. The generation should be within the limit minimum to maximum, and also we having equality constraint. The sum of power generation should be equal to the actual demand. If we neglected the loss, if you consider the loss, then we have to add a loss also. Let us take the simple case with we have neglected the loss. So the equality constraint now should be sum of power generated equal to demand. This is what the economic dispatch problem. Now let us try to implement the same economic dispatch problem in the Matlab with help of the toolbox. So for that I have taken one 7 generator system. and the coefficients I listed here: A coefficient, B coefficient, and C coefficient. And for all the generators, 7 generator, let us take the minimum as 0 and maximum 600, 100 megawatts, 150 megawatts, 100 megawatts, 550, 100, 410 megawatts respectively, and demand I'll take 400 megawatts. Now the same thing. Now first we need to create the optimization function in the Matlab. Then we have to give that same name here with the with starting with that symbol. Now let us try to see how we can create the economic dispatch fitness function. I'll open first a new file, and again I'll open new function file because I have to create a function. So once you created a function, click the function. It will show the standard format. This is what the standard format. Better I'll show you. I'll save first. So I'll save this as a ED OPG, economic dispatch objective function, and I'll change the name also. Even if you not change, no problem. Just show the warning. Better we'll replace this with the actual name of the objective, that is name of the file. Then again we are going to have variable called x. Let us take that variable as x input variable. Output I'm going to get the cost, minimize the cost, minimize the fuel cost. Now I'll try to make the process. So see, we have actually taken 7 generator here. So there are 7 input variable it will get. Now, right, then we have to type this equation, right? That is AI generators, that is GA squared plus BA GA plus CA. For that I need to get first AI BA CA values. I'll just take the cost coefficient ABC, and I'll copy this and I'll post it there and keep it there. So this is ABC variable, ABC. Then I have to create a function. So there are 7 generators. So we need to do the, that is we have to get the cost of each generator. Then finally we have to sum up everything to get the total cost. Right. So first generator cost, second generator cost, and up to 7 generator cost. After that I have to add. For that I'm going to use for loop instead of getting one by one. We can use a for loop. So within a for loop I can get the cost of all the 7 generator. Then I can finally sum up. I'll do that now. So for that I use for loop. I start from 1 to number of generator. For our case the number of generator is 7. So for loop I equal to 1 to 7. Then I'll go for calculating the cost. Let us take that function as f. I'm going to store all those things. So let us take one by one. F5 for the, this is for the first generator. So the equation we know A squared, that is A into PGA squared plus BA into PGA plus CA. That is what the function. So we'll use that. We'll do that now. First A of I, that is first function, into so the now the PGA is actually variable called x. So this is what actually PGA, which has the 7 generator output. So I'll replace this with the x of I squared, AI into x of I squared. That means PGI squared plus B, that is the second B coefficient, into x of I again plus Ci. Now the I changes from 1 to 7. For a first generator, it is 1. So A1 means it will take the first variable 0.00775 into the first generator output squared plus second B1 20 into the X first generator output plus 0. Likewise, it will do for all the 7 generator. The iteration run for 7 times, and the finally it have all the 7 generator cost value. Okay, this entire loop will get in a single time. That is it will run for actually 7 times. So each time it will get the actual cost of a generator. So after this iteration we'll have a variable called f, where we have all the 7 generator cost value. But the problem is you have to sum up everything, right? That is what actually the overall fuel cost. So for that I just use a variable called cost, and I'll sum everything. For that sum, we have a keyword called sum in the Matlab. With that, I'll use sum and I'll put f so that all the variable will be added. Then I'll put end to close the function. Okay, this is what now the objective function actually. So we have created the one function where I specified the input variable and output variable. Input variable I take it as x. You can take any variable, no problem. Even you can take z, y, whatever maybe, but the same thing must use in the calculation part also. Then for calculating the fuel cost, we need a ABC variable, cost coefficient. So that I typed here, ABC for all the 7 generators. Then I try to get the cost, fuel cost of all 7 generators. The first generator, second generator, so on by means of a for loop. Then we are summing up everything to get the total cost. So this is what actually the objective function. So once we have created the objective function, next we need to go for a toolbox. Let us go to optimization toolbox. Now, first, as I told, we have to specify the actual function name. That must be start from the at symbol. At the function name is actually ed underscore obj. Ed underscore obj. Yes. Check once. Yes. Ed underscore object. Then the number of variable here 7 because we have taken 7 generators. So the number of variable is 7. Then constraint, we don't have any linear inequality constraint, but we have a linear equality constraint. See, actually, linear equality constraint is, if you see here, they're given everything side. You can, if you want to any help, you can refer this. See, if you want to know about constraint, you just click the constraint where they specified everything clearly. So linear inequality means it is in the form of ax less than or equal to b. Okay, where A is the vector, actually B is the A is the matrix, B is the vector. So for this particular economic dispatch, there is no linear inequality, but we have a linear equality function. That means the sum of power should be equal to, there is sum of generation should be equal to demand. So we have taken demand as a 400. So it should be in the form of A equivalent X equal to B equivalent. So now the B equivalent is like a demand. So that I taken as a 400 megawatt. So I'll type B equivalent as a 400. And A equivalent actually it's sum of all the power generation. So sum means will A into X. So X is actually the variable called output of a generator. So we have a 7X actually, X1, X2, X3, which is correspond to P1, P2, P3, P5 up to P7. And the summation of all that P1 to P7 should be equal to 400. That is what the actual linear equality for this particular problem. So for that I specify here, we have a 7 generator, right? So I'll put 1, 1, 1, 4, 5, 6, 7, 1. So that's if we multiply this is A equivalent into X. X is actually the generation, power generation. So maybe first power generation, let us say example 50. 50 into 1. Second one, let us say 50. 50 into 1. So 50 plus 50, 100. Then likewise, just multiply the actual, this variable, whatever we put here with the variable we got. And we try to verify the summation of all those things as a 400. So this is the way you have to represent the linear inequalities. Okay, this is demand, and I just put all has to be sum. That's it. All the variable has to sum. All the generator output has to sum. For that I put like a matrix with the all are 1. So now it will check for P1 plus P2 plus P3 up to P7, which is equal to 400 or not. Okay, this take it as a linear constraint. There is no inequality constraint, but we have a linear equality constraint, which is actually Ax equal to B. That is sum of power equal to demand, that I represented here. Then we have a bound also, right? So you can see in this PPT, the minimum bound. So we have taken for all the generator, the minimum is 0. The maximum is 600, 100, 140, 100, 550, 100, and 410. So we will just put now that. First I'll take minimum. So minimum we have to keep 7 0 because we have 7 generator. 1, 2, 3, 4, 5, 6, 7. We close the bracket. Then upper limit. The first one 600. Then second one 100. Third one 140. Fourth one 100. One 550. Sixth one again 100. Seventh one 410. This is the upper limit. We'll close the bracket. There is no non-linear constraint function. There is no integral variable indices that we can left alone. So once we have given all those things, we can go for a optimization. We can click just optimization by clicking the start button. So I'll repeat the process again. First, we have to create the fitness function based on the problem statement. Then you type that name of the fitness function here, started with the at symbol. Put at symbol, then the name of the function we already created, the number of variables, and for that variable, if any linear inequality that we have to specify here, if any linear equality that we should specify here. Then bounds. Obviously, all the problem must have some bounds. All the optimization problem that we have to specify here in the lower bound as well as in the upper bound. So once you have specified everything, then we can go for a solver. Let us click start. So it will run. It will start the optimization. We have to wait for some time to get the answer.
Divyak,
Pondi?
Sir.
Are you able to hear me?
Sir.
Yes. Yeah, we can wait. Pondi, not able to hear you, Pa?
Sir, your voice is breaking, sir.
Okay, so 1 minute, side checking. Is it okay, sir, now?
Yes, sir,
Yes,
clear.
Pandi. Yes, Pandi. Now it is okay.
Okay, I'll show you that. You can see that this is actually the final optimization result. So we actually got the fuel cost as $9,746 approximately, and you can see the 7 generator output. If you sum up all those 7, we'll get approximately equal to the demand 400 demand. Right, so this is actually the solution variable x1 x2, that is the generator 1 output, 2 3 4 5 6 7 output. Then the overall fuel cost is $9,746.6267. Okay, so final optimization we can get here, and the solution for that particular problem we can get here, the variable, optimal variable, we can get it from this final point. So this is how we can use actually the toolbox to solve the optimization problem using genetic algorithm. Even if we can use this for a multi-objective also, once we click multi-objective, the same approach. Only thing, you have to create objective function, then we have to specify the name. We start off by the at symbol. Remaining thing and all same approach. So same thing we can also do by typing the programming in as a M file. Because the problem with the optimization technique is that they have a definite the methods like the selection, reproduction, mutation, crossover method. We can't remodify it actually all those. Yes, we have a possibility to include our custom function also. Even we can create own mutation function, and we can specify the name of that own mutation function here, same way by putting at symbol. So or else we can also use the entire programming approach. In M file we can type all the process, we can create all the process. With that also we can solve the problem using a GA approach. We'll try to do the same problem, the mathematical problem which you uh, created before, and also we try to solve this economic dispatch problem by creating the MATLAB code. So before I get into that, if you're having any doubt yeah, on the optimization toolbox, please let me know, sir.
Fanti, can we go for hybrid optimization here, pa? Optimization
Yes,
using
sir.
this tool.
Multi-objective we can do, sir, with this actually.
Okay, hybrid we can do. We can combine two
Yes.
algorithms. Yeah.
Now, to optimization, actually, the toolbox offer only GA and other optimization simulated annealing.
Okay.
Other than this, like PSO and D, those things we can't perform, sir, in this optimization toolbox.
Okay, only limited. Yeah.
Yeah, we can go for hybrid actually. Hybrid instance, we are asking for using two in single.
Yes,
That
yes,
is
yes, yes.
that we can't do, sir, here.
Okay,
For that,
okay,
we need to go with only M5.
okay. Researchers, you can discuss your problems too.
So if you have any doubt on this optimization toolbox, please let me know. Otherwise, or else we'll go for programming approach.
You can ask. Others also you can communicate. Infancy.
Okay, so if no
Krishitamaran.
doubt, we'll go for
Okay,
programming.
okay, okay. We can move on.
Now let us try to solve the same two problem by means of a programming approach. So let us, I'll show you again the mathematical function. So this was the mathematical function. Let us try to solve this by means of the programming approach. So we already created the objective function for this is what the objective function, right? Function z obj of x. This is what the objective function for the mathematical equations. So let us, I open the GA programming. I have a standard GA programming. We can use the standard GA programming. Only thing you have to replace the optimization function, that is objective function, with the our optimization function. I'll open this. Since this is different, there are different function. I'll open that actual file. This is what the first main file, ga.m. Uh, the first we need to specify the number of generations. It is sense number of iterations, and it is user defined. We can define how many number of iteration or how many number of generation we want to perform. Then population size also you have to specify. See, population size in sense, as I told, it is a such space, right? How many number of individual you want to create. Again, it is a user defined. We can specify the population size also. Then for crossover mutation, we have to specify the rate, crossover rate and mutation rate. And again, it is also user defined. We can specify the crossover rate and mutation rate, and both should be between 0 to 1. The crossover rate and mutation rate should be between 0 to 1, and we can choose by means of a trial and error method. We can choose this best crossover rate and mutation rate. And even nowadays they are going for hybrid to get the actual mutation rate or optimal mutation rate, and also crossover rate. Then we need to specify the number of variables. So there in toolbox you type straight away number. The same way here we can also specify the number of input variable. So the same problem, so I specify the number of input variables too. Then this and all keyword, and we are going to solve the global optimization technique. So I have to type global and optimization technique. The method which we are going to use, GA. So GA is a keyword to go for a optimization process. Then I just want to show the iteration graph. For that I use the figure command. So figure means it will take the empty figure window, and there it will try to draw some of the graph based on whatever command we are giving. So generally if you have a multiple figure like 2 or 3 figure, you just name figure 1, figure 2, figure 3, so that you have a different figure. So if we keep only without figure, if you try to draw multiple graph, what happen now, it will sometimes it will overlap. If second figure may overlap with the first figure. Similarly, the third figure may overlap with the first figure or second figure. So to avoid, we are still using this command. If I keep like a figure, and then I go for any plotting function, then it'll take on empty figure window, and it will do the plotting of a function. Then if I want to plot other one, I can type like a figure 1 or figure 2 or figure 3, whatever may be the, so that I can get a different figure. Not it won't be overlapped. For that only we use this command. Then we have specify the and also I made the figure background as a black background. So for that we use this command black bg, black background. And for that we also return a function. So this is actually function. It is not an inbuilt function, it is a user defined function, block bg. You can see there I already written the code for block bg. Okay, this is what the standard block bg code. And again, it is actually downloaded from the internet only, this function. Then we need to specify the name of the objective function. So I already typed the objective function. So the same thing, right? Same thing, x with the same mathematical function I will type. Only thing, instead of widget I put y. That is not a problem. Same function I will typed here. So that name of the function should be specified here as a name. In single quotation you have to type. This is the normal format. Then we have to specify the range. Range means the maximum limit and minimum limit. First for a first variable, then column second variable. First variable 0 to -10, we already seen that. Second variable again, I think first variable, both variable +10 to -10, right? So first variable minimum function, maximum function. Similarly, that is first variable minimum function, both are, this is minimum function and maximum function. Let us change it both for -10 to +10. So first variable minimum is -10, maximum is +10. Similarly, second variable minimum -10, maximum +10. Okay, so just I typed it here. Then this command we generally use rand seed 1000. This is actually to make to generate a random number always same. See, because in the process like roulette wheel selection or mutation process, we use sometimes random number generation. So if I specify like this, we always get a same result. If I'm not specify this, if I'm not use this line, whenever you run this program, always you'll get a different answer. Why? Because random number we use, whenever we use a random, it always try to generate a different numbers. Maybe if I run first time, it will generate 100. For that, we'll get some solution. Once I close, if I run for again second time, it will randomly generate number as 200. So obviously we won't get the same result time to time. So for that, to make always get the same result, we are using this command rand in bracket seed with the random number. We can use any number, 100 or 200 or 500 or 600, whatever may be, which specify always the standard format to generate a random number. Okay, for that we are using this command. Then once you, this and all actually use a variable specifying the number of generation, population size, crossover rate, mutation rate, number of variable, and the name of the objective function, and also minimum and maximum range. Once you have specified everything, then we need to go for the common steps which we already discussed. You know that first step you have to create a populations. Once you have selected a population, you need to go for a fitness function calculation. So once you find the fitness function, then we go for a selection, then reproduction. Inside the reproduction, crossover, mutation. Then again we have to repeat the same step. That is what the common steps it is involved in genetic algorithm process. So same we are doing here. I'll try to first generate the populations. So I'll use a variable called populations. See, we know that there are two variables here, right? X and Y. For that, we are generating a population. So this is the standard equation. See, if I want to generate a number between -10 to +10, this is what the normal equation. Okay, range 2 minus range 1 plus range 1. So this is what the general formula. That means B minus A, that is the random number into B minus A plus B. If you keep this one, we'll get a random number, any random number between the limit we have given, -10 to +10. So all the algorithm, whatever the algorithm you're having, for all the algorithm, use the same formula to generate the population. Okay, it may be differentiation, or it may be PSO, or it may be any new algorithm, a Firefly algorithm, or uh, uh, any new algorithm, we use actually this particular formula to generate a population, right? If variable is 5, you have to keep variable as 5 or 6 and so on, right? So once we have created the number of population, you need to go for crossover. So that has to be done repeatedly until we reach the maximum iteration. So for that, I'm using a for loop here. Okay, there I'm just allocating memory for all the variables for generations, that is upper average lower, and I am storing crossover rate into PC and mutation rate into PM. Again, it is choice only. We can even use XOR rate for wherever we are going to put the crossover rate, and mutate rate wherever we are going to use mutate rate. It's just option only. We just again storing XOR rate into PC, mutation rate into PM, or else in the first step itself we can keep PM PC, so that no need of these two lines. Then we are starting the iterations. First we are getting the for all the individual, we are trying to get the fitness function. This is what the objective function evaluation. So evaluation of population we are trying to get. So that is actually a function. You can see I have put evaluation population here, where you can see we are getting the evaluation for all the population. Again, if you go inside the function each, where we are calling the function we have put as objective function, this function. So each time when we call this function will be executed, and whatever the input variable x, it will do the calculation and try to get the actual answer, and that will be passed to the main program called a GA. So this will be done repeatedly until we reaches the maximum iteration, right? So now inside the operation all will be done. You can see that inside the operation, initially we are doing selection process. Here we are actually using the roulette wheel selection. This is actually roulette wheel selection. We are rotating random. We are performing permutation method. That is, we are just rotating until NP terms, and we are choosing the best individual. Then we are going for a crossover. Here we are using a binomial crossover. This is a binomial crossover process. So once you are done with the binomial crossover, then we are checking for range, because so once you and change the numbers, right? Once we perform some of the operation, it is obvious that the variable may exceeds limit, right? We have set limit as -10 to +10. So it may sometimes exceeds once we do the matching operation, right? So that we have to check whether if anything exceeds the actual limit. If it is so, we have to set whether it is a minimum limit or maximum limit. Otherwise, I need to go for other populations. So once you did, and we need to go for again the actual selection process. Then that is, so once this will be again move over to the actual main program GA. Then this process will be repeated until when the maximum generation reached. So the maximum generation I kept as actually 1000. So this entire for loop will run for 1000 times. Then after that it will give the actual output. Then we are just displaying all the output, and also we are plotting the curves for all the generations. I'm just plotting the upper value, average value. We are getting upper value means it's the maximum, right? And average mean of all the function, and also we are drawing the lower value. So all together I'm putting, and I'm just trying to plot the function. So this is what the standard program. We can use the same program for any problem to solve. Only thing we need to know how we need to replace the ranges. Now we need to replace the objective function. So that we know, we can simply able to solve any of the problem using this particular code. Now I'll run this code. Let us try to check whether what answer we are getting. See, this is it is giving answer as actual answer is optimal value 0.0071, and it is giving x variable as 0.3913 and y variable as 0.439. This I actually have declared in the result. You can see in the result part whatever optimal we are getting, I'm putting that to get the actual answer, and x1 is actually x and y1 x2 is actually y, right? And optimal is y. That both are displayed here. X and y are displayed, and also I also displayed optimal value. So optimal value we are getting 0.0071, the optimal x 0.3913, optimal y 0.4301. So even if I want to get the result better than this, I can randomly changes the XO rate or mutation rate, or maybe you can check with the different generation or different population size. Let us try with the different population size. I will change this 50 to, let us say, example 100, and I'll change generation maybe to 500. Let us see if any changes are there in the result. Yes, we have some other optimal now, right? You can see now the optimal x is minus 1.33, minus 1 point y is minus 1.3462, and the optimal answer is 0.0718. So this is how we can also uh, get the optimal result. We can do trial and error method. We can change the user defined parameter like number of generation, number of population size, crossover rate, mutation rate. By changing this four, we can get the actual the expected answer. That is minimized answer or maximized answer. Okay? This is how we can also make a programming approach also to solve the problem using the optimization. Now let us try to apply the same for the economic dispatch problem, uh, which you already solved by means of the toolbox. The only thing I have to replace the objective function and also some of the parameter like number of variables and a number of minimum maximum function. Let us do that now. Close this and let us already created that the same function GA, same program. Only thing for now economic dispatch, you have taken 7 generator, right? So the number of variables 7, and I also specified the range for all. First generator minimum 0, maximum 600. That is what you have seen before. Minimum 0. First generator minimum 0, maximum 600. Then second generator 0 100, third generator 0 140, fourth generator 0 100, fifth 0 550, sixth 0 100, and seventh 0 410. So this is the minimum maximum bound. Only I change this line and also this line. Remaining thing I'm not change anything at all here, right? Then I need to change the objective function based on the problem statement, right? So I already changed it. I'll just show you. So same thing, I'm getting x variable, and I'll explain this thing later on. Same, we already written, right? ABC cost coefficient, and I am just putting for loop to get the cost of each generator, and finally I'm summing up it, right? So one more thing in this problem, actually we have to specify the equality constraint also, right? But in the programming approach, so there is no option directly to add a the equality constraints. So that we need to do by means of the concept called the penalty concept. In the toolbox, we have option like ax equal to b. So there I put the demand as a 400, and straight away it will check and it will give the accurate answer. But in the programming approach, generally we use different ways. Generally we use the penalty approach. There I'll check the sum of all the power which is equal to demand or not. If all are equal, I'll make penalty as 0. Initially I keep penalty as 0 and it will check for some condition. The condition is whether the sum of all the generator output equal to demand. Demand I set it as 400. If it is not equal to 0, we add some penalty. Let's say you generally take penalty very higher value, and then I'll add that penalty with the final answer. The concept is if the demand is not equal, that is the power generator is not equal to demand, obviously it will add a demand so that the cost will be increased, right? So what actually the solution will get a higher solution. So now what the optimization try to do, the optimization always try to get a minimum solution so that it always look for a solution where it will have a penalty as 0. If take penalty as 0, obviously it is going to make demand as the 400 megawatt, right? The same way we can do for any equality constraint. Same thing we can also do for inequality constraint also. Generally in programming approach, if you want to integrate any the equality or inequality constraint, the best approach is going with the penalty function. You check for a condition. If the condition is met and you keep penalty as 0, if it is not, you put some penalty and you add that penalty to the final answer, so that the final answer will generally large. So that will be worst solution, right? Because our objective is to reduce the function. So the optimization algorithm will neglect those things and it try to get the minimum value so that it also makes the penalty as 0, right? So this is how I made it. This is actually objective function. So only thing we have to change here, This entire program you have to change based on the actual our problem statement. This I already changed it, and also in the result part I have to change. I have written one function to display all the result. This line, I just open this. You can see same I written. Only thing I just displaying final result, the optimal x value, that is 7 generator output variable, and I'm just checking whether it is matching the demand or not. Then also I'm displaying the final optimal cost. So these three things I am displaying as an output. Remaining thing and all same. This is actually final optimal x. With that I'm trying to get the cost for the final value, and I'm just displaying all those final value in the result part. So only thing you have to change, you can take the same program. Only thing you have to change in the first step, that is like how many number of variable the particular problem having, and how and what are the range of all those variables. That two you have to specify. The remaining are user defined. Generation, population are user defined, and also you have to replace the objective function with your problem statement. And the same thing also you have to put in the result also. There you need to make what are the data you want to display, what are the result you want to display, that you can type it here. And then I'll run this program now. You can see this is actually convergence graph. You can see the fitness graph. So actually it is not predicted the exact demand. See the demand we have set it as 400 megawatt, but the addition of all the generator giving only 395. That's why it added the penalty also. Okay, so if you want to get optimal solution, you can go for trying a trial and method. You change all those parameters like the generation, population size, crossover rate, mutation rate. At one optimal value, you'll get exact the demand as 400 megawatt, and for that we can get the solution, the generator solution. This is what the 7 optimal output of a generator. So this is how we can use programming approach to solve any optimization problem with help of genetic algorithm. Maybe I'll change any of the variable crossover rate. Let's see whether we are getting any different answer or not. Instead of 0.9, I'll take 0.1 as a mutation rate, and crossover rate. Mutation rate, let us take 0.8, 0.08. Let us see whether we are getting any different answers. Yes, we are getting somewhat different answers. See, now the generation could change, but still the power generation is not 400, right? Demand is 400, but power generation we are getting 350 only. In the last case, we got nearly 395, but here only we are getting 350. That's why we are having some actual high optimal cost. So likewise, I can randomly change all those things, all those parameter, and I can get the exact 400 megabyte demand. That will be the final answer. That optimal cost as well as optimal generations. Um,
Pandi?
Sir, shall you close or else shall you take one more application, sir?
Pandi, can you take some general
Sir,
application? Any other
sir,
application?
sir, excuse me, sir.
Yes,
Yes.
sir.
Sir, really, it was very nice presentation, sir. Also, you have uh, highlighted every concepts nicely. Actually, sir, we are beginners in this field, sir, in optimization field.
Okay.
May I ask you a specific example, sir, from my experience?
Yes, sir. Yes, sir.
Sir, as I said already, I belong to image processing domain, sir. In that,
Okay,
currently
sir.
we are working on a problem in image
Okay.
denoising. Actually, there we using
Okay. Okay.
multi-objective optimization technique. Actually, I don't know that optimization part much. Another professor from
Okay.
Mahalingam University he's been working and helping us out.
Okay, sir.
But I
Okay.
want to learn in this domain. So I want to make the terms what you have used here in this session, sir, is
Okay.
all the terminologies what you used is a general terminology that you used to use in soft computing, right, sir?
Yes, sir. Yes, sir. Yes, sir.
like
If
population
you see any
size,
of
crash over rate,
population, all are
mutation.
common terminology, sir. Yes, sir.
Common terminologies that used to be used in optimization field.
Yes,
But
sir. Yes, sir.
my the problem I faced while understanding how you, the way you explained, and the knowledge you have in this is really amazing. It helped us much to, as a beginner we learned so much, but I faced a small problem, difficulty to
Yes, sir.
travel along with you while you're using these such terminologies. If
Yes.
you explain me with this example, there may be a chance for me to travel along with you. Like
Okay. Okay, sir.
sir, I we choose a noisy image, sir. Usually we choose a noisy image.
Okay.
In that denoising algorithm we have two threshold values
Okay.
to detect a pixel as a noisy pixel or a non-noisy pixel. We used to
Okay.
have a threshold value. To
Okay.
estimate that threshold value, we going for a optimization technique.
Okay. Okay, sir.
Okay, so in this example,
Uh,
what exactly this population size is, sir,
yeah.
in this scenario?
Yeah. Yeah. I understood, sir. Actually, if you are taken some noisy feature, right, sir? Right, sir?
Yes, actually, sir, our optimization technique is
Uh,
applied for each and every for each image. We have a different threshold value. We derived a different threshold value. Before
okay.
applying this denoising algorithm, we should train that particular image for this optimization uh, algorithm to derive threshold value.
No,
The final
sir.
answer
Actually,
optimized.
population, sir. Population is nothing but it is a solution, sir. That's it. It is a different
Okay,
solutions for that particular problem.
okay, sir. Okay, sir.
Um, you can understand the mathematical functions. If I want to solve, for example, second order equation x squared plus x plus 5, the x
Okay,
squared
sir.
may be any numbers, right? It may be from minus infinity to plus infinity. That actually we used to call populations. If I
Okay,
specify the
okay, sir.
range,
Okay.
I want the x should be between minus 10 to plus 10. See,
Okay, sir.
if that
Okay.
particular function correspond to cost function, obviously the cost would not be negative at any point of time. So cost would be above 10, right?
Yes, correct.
It should be above 0, right? So likewise, we have
Yes,
some
correct, sir. Correct.
way to represent the population, sir.
Okay, sir. Okay, okay.
Simply we can say population is actually a solutions, a different solution that we used to call populations.
Different solution. We
For
choose
a
different
particular.
scenarios. For that
Yeah,
different
yes, sir.
scenario, we
Uh,
will derive solutions. Those
yes,
solutions we
sir.
used to call as population. The number
Yeah,
of
yeah.
scenarios
No,
we
no, no,
choose is
so
called
not
population
solution.
size, right, sir?
Solution we used to call fitness. For
Okay,
getting
sir. Okay.
solution, we use some variable, right, sir?
Yes, sir. Yes, yes.
That we used to call populations. Actual
Populations. Okay.
population we create randomly.
Okay.
Then using the optimization algorithm, we try to get the optimal population. That will give optimal solution.
Okay, fine, 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 sir. See, sir, if my problem is PSNR value,
Okay, yeah.
after after denoising, denoised
Uh,
image will be compared with that original image.
yes, sir.
It will be quantitatively evaluated using PSNR, peak signal to noise ratio. It
Noise
should be
ratio, yes,
high.
sir.
Yes,
Yes,
it
sir.
should be high actually. So
Okay.
to get a high PSNR value, my objective here is PSNR
To
value.
maximize,
PSNR
yeah,
value
maximize the PSNR, sir. For PSNR, you have
maximize
some
PSNR.
mathematical equation, right, sir? That means you have to reduce the noise so that the PSNR
Yes,
will be high.
yes, yes, sir.
So you have to choose the actual reduced noise. So maybe for noise calculation, you have some equations, right, sir?
Yes, sir. Yes, yes, sir.
There you have some variables, right? That we need
Yes,
to
sir. Yes,
get
yes.
based on the optimization algorithm, sir, or any other algorithm. That variable used
That
to
we
call
should
actually
fit with that fitness function.
PSNR is the fitness function,
How
sir.
to derive that fitness function, sir?
It depends on your problem, sir. Problem statement. The object
Okay, okay, okay.
fitness seems it may be minimum maximum. Sir. your problem is to get the maximum PS, right, sir? And that. Hello, sir.
Hello, sir. Sir,
Yeah, I'm
actually,
audible, sir.
your voice. Yes, sir. Now you are audible, sir. Now you are audible.
Yes, sir. That it depends on the problem, sir. We have to make that fitness functioners. We have to model based on the problem statement, sir. We have
Okay,
to derive.
okay, sir. Those coefficients, it will be always an linear equation, right, sir?
No, sir. Non-linear equation also we can solve by using optimization. It is not mean that it should be a linear one.
Okay, okay, sir. How, if it is non-linear, how to derive that equation, sir? Is there any specific method, or it is our?
No, it is based on the knowledge on that particular domain, sir. We need to only
Domain. Okay,
create the
sir.
mathematical model.
Okay, okay.
For solving, we can use this optimization, sir. But problem we have to define.
Define. Okay, defining the problem is actually the main work,
Yes,
right,
sir.
sir?
That is the
If
main
we
thing. Yes.
define our problem correctly, then we will get optimized
Yeah. We
solution,
can easily
obviously.
solve by means of a standard optimization algorithm, sir.
Okay, sir. Okay, okay. Sir, I one more doubt for me, sir.
Yes, sir.
You mentioned about genetic algorithm, fuzzy logic method, and
Yes, sir.
yeah, you
Yes.
mentioned. I
Yes.
heard about few other optimization techniques like ant colony
Ant colony,
optimization, bee
yes, sir. Yes.
colony.
Ant colony, bee colony, yes,
Uh,
sir.
how it differs actually from these three methods, sir? Or they are just a part of this
Yeah.
algorithms to
All
derive
are
the.
derived. So all are derived actually from genetic algorithm only.
Okay, sir. Okay.
Hello, sir. This is Siddharthan. Uh, Sir,
Actually behave.
Funding?
So based on that, they made actually the process. They named the process. But if you see inside it, there also we having same some mathematical equation. It may be somewhat different from the GA process, GA equations. That is the selection crossover, all those things.
Okay, sir. Okay.
hello, sir.
Yes, sir.
Uh, Sir, I have the actually I have the objective function and or fitness function
Yes, sir. Okay, sir.
for the motor control,
Okay, sir.
for which I need an optimized solution for it. For for better optimization, using either a genetic algorithm or fuzzy logic algorithm or AI algorithm, which one is best? Whether I need to do the steps again and again for all, each and every solver, or is there any method to compare at the time all the three
Yes,
methods, sir?
yes, sir. You the problem. What is your problem, sir? Please, once problem.
Actually, I have the objective function. The objective function is based on the motor control, sir. I
Okay.
have the objective function or fitness function,
No,
which is actually
motor control. No, motor. You are controlling what the motor speed, sir.
speed control, sir.
Speed control. Okay, sir. Okay, sir.
ஸோ என்னோட ஃபங்க்ஷன் வந்து சார் டார்க் மேக்ஸிமைஸ் பண்றது, அதுக்கான
Torque.
ஃபிட்னஸ் ஃபங்க்ஷன் என்ன இருக்கு? மேக்ஸிமம் டார்க் பெர் ஆம்பியர், which means ஃபார் மினிமம் ஆம்பியர் ஐ வாண்ட் டு கெட் த மேக்ஸிமம் டார்க்.
Okay, sir.
For that I need to control the current, for
Current.
which
Okay.
I have the objective function and also or fitness function, sir.
Okay, sir.
So I need an optimized solution for that function. I have two
Equation.
variables.
Okay. Then you can
Yes,
go with you can go with the optimization algorithm. Any of the optimization like a GA, any of the recent optimization algorithm, sir.
Yes, sir. That's what I'm asking. Which, for example, I want to do all the three methods. For example, the genetic algorithm method, AI method, and also
Actually,
I need
all no, optimization is a different domain. ANN is a different domain, sir. That we can't compare actually.
Okay.
ANN it's like predicting something by giving the actual input and output. It is like our human brain mimics process. ANN.
Okay.
ANN is completely different from optimization. Optimization
Okay.
is to get the solution for the particular optimal solution for the particular mathematical equation, sir. பட்
Yes,
ஏஎன்என்
sir.
வந்து ஏஎன்என் வந்து உங்களுக்கு அது வந்து ஒரு நீங்க ஒரு அது ஒரு டிஃப்ரெண்ட் கண்டிஷனுக்கு வந்து அதை நீங்க ட்ரெயின் பண்ணிட்டு நீங்க ஆக்சுவல் இன்புட் கொடுத்தீங்கன்னா இட் வில் கிவ் அவுட்புட். You can convert your problem also into ANN problem, sir. Only thing, you need to collect the data. So you told that your optimization is to get a maximum torque, right, sir?
Yes, sir.
Which
Maximum
depends
torque
on other,
at minimum ampere.
okay, minimum current and maximum torque.
Torque. Yes.
That is single thing, right? That is always defined. Your objective is to get always maximum torque with a minimum current.
Yes,
That
sir.
we can directly solve only with optimization. So AN, where we use ANN is that ANN is like if I want to forecast, let us say example, I want to forecast the tomorrow the weather condition.
Okay.
That may change, right? So that is there is no definite solution for that. There is no one solution, right? So answer will be anything based on other parameter like tomorrow timing and tomorrow the other environmental factor. Based on that, the weather condition may change. For those
Yes, sir.
applications that is like prediction application, we can go for ANN, sir. ANN optimization we can't compare.
Okay, sir. One more question is, if I am doing genetic algorithm, there is you have to trial and error method. You said that it is mutation rate and crossover rate.
Yes, sir.
சார் அந்த மியூட்டேஷன் ரேட்டையும் கிராஸ்ஓவர் ரேட்டையும் நான் வந்து மேனுவலா சேஞ்ச் பண்ண தான் முடியுமா? பாராமீட்டர் ஸ்வீப் ஏதாவது பண்ண முடியுமா சார்?
பாராமீட்டர் ஸ்வீப் பண்ணலாம் சார். நார்மலா அப்ரோச்சும் பண்ணலாம், இல்லைன்னா நீங்க ஹைபிரிட் பண்ணலாம். இன்னொரு ஆப்டிமைசேஷன் வச்சு இந்த பாராமீட்டர் வந்து நீங்க டியூன் பண்ணலாம். தட் வி யூஸ் டு கால் ஹைபிரிட் அப்ரோச்.
ஓ, which means in the mutation rate and crossover rate will be automatically changes with respect to
yes sir,
iterations.
Iterations, yes sir. I'll take one more algorithm. Let us take PSO, particle swarm optimization. அதுக்கு வந்து நான் இந்த மியூட்டேஷன் ரேட்டையும் crossover ரேட்டையும் I'll give it as a variable.
Yeah, okay, I understand, sir.
But again, that is not a good approach actually, because again for a PSO we have some variables.
Okay, sir.
So no option. We need to go with the trial and error method only, sir.
Okay.
Then we do with the trial and error method. But like for ANN, we having some of the variable like the same like number of iterations and also some learning rate. Those things. For those things, they generally go with the hybrid approach, like a GA or genetic or a PSO.
Yeah. Okay, sir. I understand.
Participants, if you are having any doubts, you can ask. Any other clarifications? Siddharthan sir?
Yeah, yes, sir.
Shall we conclude, sir?
Yes, sir. Sir, thank you so much, sir. Actually, I don't know anything about optimization. This is, I think, I am on LKG class. I feel like in an LKG class, but I gained the knowledge such that what is actually population, what is how to what is fitness and all, what is selection, and how to what are the steps which is taken, and what is mean by reproduction and all. And I gained some knowledge about this thing, and I will always use this in motor control, sir. And most probably I will call you or I will mail you for my type of problem.
Yes, sir,
And
sure,
our staff also I think will get the much knowledge from you. And thank you so much, sir, for wonderful knowledge you have shared with us. And we thought we will get future reference also with you. And thank you so much, sir. Thank you, Achudi, sir, for arranging this wonderful seminar. And thank you so much. And participants, you can fill the feedback form which is given in the message box. You can after filling the feedback form, you will get the certificate. Thank you so much, sir.
Thank you, sir.
Pandi?
Sir, thank you, sir.
Pandi, on second, Pandi. 1 minute, Pandi. We are having people from different domain, Pandi, especially from mathematics, mechanical.
So actually, I thought of
Yes,
you
yes,
know all are already know about optimization, and that's why I went so fast.
Yes. No, Pandi. It is very clear. You explained very clearly.
Okay.
But one thing I want to tell you is when they are solving some problems, they may get some doubts.
Yes,
Now
sir.
it's clarifying.
Yes, sir.
Okay.
Yeah, sure, sir. Sir.
Okay. Okay.
Please
I
note down
will.
my details, sir. If any
Sir,
doubt, yes, sir.
sir, Karupasamy sir, really it was very useful, sir.
Thank you, sir.
Sir, we actually for your session we planned in every domain we can use this optimization method.
Yes, sir. Yes, sir. Yes.
Sir. Now bridging one domain and another domain.
Yes. Yeah.
Optimization is a bridging domain actually. Each and every researcher is looking for optimization engineer. So
Yes,
it's
yes.
a very important domain. So here we are from multiple disciplines,
Okay.
max department staff, mechanical engineering department staff.
I thought I have all electrical bill. That's why I
No,
complete the electrical
no
application.
issues, Pandit. I hope they.
No, sir. It was no, sir. No, actually, it can be adaptable, sir. Your example was really uh, very practical, and it helped us very much to understand. Sir, my another request is we should work together, sir. We are all
Yes, sir.
beginners in research. We may know tools, but we don't have much experience in publishing journals or other research activity. We need your help or
Sure, sir.
association to work
Yes, sir. Sure,
together
sir.
in future. I request you to may consider us as an associate, sir.
Yes, sir. Sure, sir. Any doubt,
Sir,
any classification, any of your process, you can contact me, sir,
yes,
anytime.
sir.
No
Yes.
problem, sir.
Sure, sir. Sure. Sir, myself uh, will work on Matlab, sir. I'm
Okay,
actually good
okay,
in
okay,
Matlab.
okay,
May not be good in optimization, but I'm good in MATLAB, image processing,
okay,
image encryption, and
okay.
so if we have any common problem, we can work together, sir, in future.
Yes, sir. Sure, sir.
Thank you, sir.
Thank you, sir. So thank you, sir. Thank you, sir. Thank you all for your active
Pandit, thank you
participation.
for. Thank you for.
Thank you so much, sir, for
Thank you very
the
much.
opportunity for
I
sharing my
have to
knowledge with
thank
you.
you. Okay. You spent a very your busy schedule with us today. Okay. Thank you, Pandi. Again, we will meet, Pandi.
Yes, sir. Thank you, sir.
With some work, we will meet again.
Yes, sir. Sure,
Okay.
sir.
After doing some work from the faculty members, again we will meet.
Yes, sir.
Okay.
Sure, sir. Thank you, sir.
Okay. Thank you,
Thank
Pandi.
you.
Thank you.
Thank you.